Okay, just going through the notes. So conductors, semiconductors explained there again. PN junction we're interested in. Okay, so let's draw it. So PN junction, we have our P-type material and we have our N-type material. Okay, P I'm going to just indicate by that. They're the holes, the excess holes, and the electrons, the excess electrons in the N-type material. Okay, so they're holes, they're electrons. Right, okay. At the junction, the electrons move over and fill the holes. So I'll be able to draw that. Okay, when the electrons fill the holes, you've lost electrons as charge carriers, you've lost holes as charge carriers. Suddenly this layer has become insulating. Okay, let's go through the charges. This is still neutral, because remember, a PN junction, a P-type material has extra boron added, neutral boron added to neutron silicon, giving you neutral doped silicon. Okay, so that is neutral. The protons that keep it neutral are buried in the nucleus. Have nothing to do with the electronics, but they're still keeping it neutral. The N-type material over here is also neutral, but the bits here are the important bits. The electrons are moved to here, so that's minus charge, and that has a plus charge. That's fierce important. Okay, that has been asked. Okay, this layer is called the depletion layer. It is depleted, or had removed the charge carriers. Okay, and it is insulating. And remember, it acts like a little power supply that is trying to move charge from right to left, and it has a junction voltage. And for silicon, it's worth knowing that's approximately 0.6 of a volt. Okay, you need to overcome that to get the current to flow. Okay, so that's it. So let's read it. When a P-N-type material and N-type material brought together, electrons move from the N-type and fill the holes in the P-type and vice versa. At junction, virtually no charge carriers are therefore present, and insulating depletion layer is formed. The depletion layer on the N-type has a net plus charge due to the departure of electrons, and the depletion layer on the P site has a net negative charge to the arrival. There's a junction 0.6 volts for silicon, and just take note that the junction opposes the applied voltage in forward bias, as we'll see here. Okay, right, forward bias. Okay, so what happens for forward bias? The plus is connected to the P, and the minus is connected to the N, and what happens is, in both cases, the charges are driven into the depletion layer, destroying the depletion layer. Once the voltage goes above 0.6 of a volt, the applied voltage goes above 0.6 of a volt, it destroys the depletion layer and becomes a conductor. Okay, and the way we draw that, it's a diode. Remember, a PN junction is a diode. That's the symbol. We say it's in forward bias. Current flows once the junction voltage is overcome, and the arrow indicates the direction of the current going from plus to minus. If the arrow is in the right direction, it's forward bias. Okay, if we reverse it, okay, so what's basically happening here is the holes are being attracted that way, and the electrons are being attracted that way. The electrons to the plus, the holes to the minus. The depletion layer gets wider, okay, and no charge, no current flows. Okay, now the last line is the one I mentioned in our earlier clip. A small current will flow in reverse bias due to movement to the minority charge carriers. That's all you need to know there. So this is it in reverse bias. Okay, that's it.